there are three charges, minus q, plus 2q and minus q, are arranged on a line as shown in figure like this. So clearly here also you can see that there are two electric dipole. One electric dipole is placed this way and the other electric dipole is placed this way, because dipole moment vector is always directed from negative to positive. So there are two dipole moment vectors. P is the dipole moment, and which is equal to charge multiplied by the distance between the charges, which is equal to A. So there are two electric dipoles placed back to back, and the point is at a distance r from the center of this configuration. Here it is a point P. So distance from centers of the dipole, is anyway going to be, here it is going to be r minus a by 2, and for the second charge it is going to be, for the center of course, for the center it is going to be r plus a by 2. You can see r is the distance from this charge and a by 2 is the distance from the center of each dipole. So r plus a by 2, r minus a by 2 will be the distance of this point from center of these two dipoles, and that is why the difference of the field is going to be because of this difference in the distance. Okay, so these two dipoles are oppositely directed, the first thing. So their electric fields are going to be opposite to each other. So anyway, the net electric field value is going to be the difference of the two, E1 minus E2. In both cases P is same, only the difference is for the distance. On axis, as we know that formula of electric field for axial location is 1 upon 4 pi epsilon naught into 2p divided by x cube. X is the distance from center of the dipole. So here in case of E1, suppose this particular E1, so distance is r plus a by 2, and for this distance is r minus a by 2. So field of this dipole will be bigger than this because this particular dipole is near to this point. So let us assume that E1 be the electric field of this dipole and E2 be the electric field due to this dipole. So even 1 upon 4 pi epsilon naught is going to be the common term into 2p is going to be the common term. 1 upon x cube is different. So 1 upon x for 1 is r minus a by 2 whole square and minus 1 upon r plus a by 2 cube for dipole. Okay, 2p upon x cube. So this is the expression, and you can simplify this electric field E equal to 2p divided by 4 pi epsilon naught into, here just take r cube as common and write it like this, 1 minus a divided by 2r raised to the power minus 3, okay, and minus 1 upon r cube if we take r as common and just put this bracket like this thing, a divided by 2r raised to the power minus 3. As you can clearly see, we have to find the field at this point for r much greater than a. So a is very small, so this number is going to be very, very small. As we know that according to binomial approximation, 1 plus x raised to the power n is approximately 1 plus nx if x is very small in comparison to the 1. So that thing we can use here. So what it becomes, E is equal to 2p divided by 4 pi epsilon naught, r cube is common, can be taken outside, and here it will be 1 minus minus plus 3a divided by 2r. I have multiplied the power here, as you can see with this particular approximation, and here 1 minus minus it becomes plus 3a divided by 2r. And of course I have made a mistake, it was plus here, so it will remain minus. It was r plus a by 2. Okay, so these two terms are going to get added. So 3a by 2r and 3a by 2r, so both combined becomes 3a by r. So 3a by r multiplied with this, so 3a by r multiplied with this becomes 6p 3a 6p a divided by 4 pi epsilon naught r cube, and here it is one more r, so it becomes r raised to the power 4. And here 6pa, p can be written as 2qa, p can be written as 2qa. So in fact p is q into a, you can substitute here, so it becomes 6qa square. So final answer comes out to be this. So part B will be the correct choice for this particular question.